So yeah, so yesterday I think we stopped near slowly changing dimensions. So till now we
Yes.
have covered things on what are the sources, what is the process through which the sources get extracted and moved to the warehouse. So in between we have this ETL process in which there is something called slowly changing dimensions. So when we say dimensions, what do you mean by dimensions, Sandeep? Yesterday we have discussed. Dimension table store, what kind of data do you think?
Tables and fact tables.
So
Dimension
dimension, when I say
will be
dimension table,
only descriptive data.
perfect, perfect. So it stores descriptive. So when I say descriptive, it could be let's say take the example customer. Okay, customer table. In my customer dimension table, I might have columns like customer name. I might have customer ID. I might have customer city, right? So age, right? So these are some of the columns you might have. Let's say suppose I'm adding a value Ravi 101 Bangalore, let's say age 32. Okay, so I'm adding one more uh, thing. Let's say a lady's name Leela and 102 Hyderabad, let's say 32. Okay, so now what happens is this is my dimension data which is stored in my data warehouse. Sometimes there might be a situation that my dimension data gets changed. So what kind of data do you think will get changed? Do you think the name of a customer will get changed? When I say change in the dimension data, what kind of changes do you think? So
The
what I'm asking, go ahead.
employee name, it can be changed, right?
Right. So customer city name can be changed. If I'm moving from Hyderabad to some other location, the name can change. Age will change
Yeah.
based on that, right? And let's say married, we have something called marital status. As long as you're single, that's fine. Once you get married, your marital status gets changed. So these are some of the data where the data in these dimensions change over a period of time. Generally, your customer data will not change, but there are certain these kind of data will you will be seeing changes in these kind of data. And how is that you're going to handle as part of the data warehousing is what we are going to discuss. So we need to handle this kind of situation. So last year probably my customer was in Bangalore. This year he might be in Hyderabad. So all this information I need to capture this. Otherwise, I will end up taking wrong decisions. I might still be thinking that Ravi is still in Bangalore, right? So I should keep updating, and I should see how I'm going to handle this kind of dimension data which is changing. So this is called as slowly changing dimensions. That means a dimension data which changes over a period of time. Slowly it will change over a period of time. So relative to fact tables, dimension records change very slowly. So when you compare with the fact tables, the dimension data will change very slowly. So some of the examples what we have seen, right? So it allows dimensions to have multiple profiles over time to maintain history, right? So if I am talking about history, let's say I'm having something called year over here. This is let's say 2012, 2013. So in the year 2012 in Bangalore, right? And in year 2013 probably he might have shifted to another place. For example, I will insert one more row of data. So Ravi is here. Let's say 101 will be there. He might have shifted to Chennai, right? And his age might have gone 33. Maybe initially he was single. Now he, like the status has got changed to married. Now year is 2013, right? So this is a change. So we are capturing the history. Now that we are capturing the history right now, I'm in my last year he was in Bangalore. This year is in Chennai. So we are slowly changing dimensions will allow to have multiple profiles over time to maintain history, right? Each profile is a separate record in a dimension table. So it is a separate record in a dimension table. And one of the example is when a woman gets married, all these things will get changed. Her last name, her marriage status, or marital status, address, household income, all these things will change when she to how are we going to handle these kind of scenarios. Let us see how we are going to do that. So existing facts need to remain associated with a single profile. So when I talk about the fact table, so fact table again will have a join with my customer dimension. So it has to join with my customer dimension. So one of the profiles, it has to join with one of our profiles. New facts need to be associated with our married profile. So whenever a new fact, let's say suppose a new transaction has occurred, that new transaction should go and join with the latest data, whichever data is there in your dimension table. So these are the three ways in which you're going to handle these kind of changes. So as part of my enterprise data warehouse, as I was telling you, you have sources and you have ETL, and then you move the data to enterprise data warehouse. Now from the sources, all my dimension tables, right? The dimension data, I will not call dimension tables because there are no dimension tables in your source. So it's just normal entity relation tables. Under this, whatever data is there, that moves through the ETL to over here to here. So yesterday we were discussing about first we will be moving the dimension data, then we will be moving the facts, then hierarchies. So all these things which are enterprise data, right? So hierarchies like this. So when you are moving the data from your source to the enterprise, how is that? What are the different ways you can do this? First, see, there are three ways in which you can handle. One is type 1, they say. So type 1 SCD, in short, these are also called as SCDs, in short, slowly changing dimensions. So SCD can be implemented in three ways. One is type 1. In type 1, what will happen is, I will not maintain any history. Straight away, I will just replace the value. Instead of having a new record, I will just have directly I will override this value and keep the same record. So I will just override the existing record. So that is which happens. Yeah.
Yeah, if you think it is an override value, just go to Excel, type 1. If you are overwriting, what do you say, his name or something,
yeah,
his name we can't rename, right?
Ravi is there.
Yeah, we can't rename that.
But why do you want
customer
to
name should be same.
Customer name will be same, yeah. But there might be a situation where your customer name also gets changed, right? Here now, a lady when she gets married, her last name changes. So,
okay, fine.
Right?
Then if you are overwriting the city name as Bangalore to Chennai, means even previous history also it will change to Chennai?
There will not be any history. In type 1, you will not maintain any history.
Okay, only one table.
Only one row. Only one row.
Okay.
Yeah. So when we talk about history, we maintain history in type 2. In case if the ETL team is implementing type 2, then it will maintain the history. So what happens? A new row will be added like this. A new row will be added. So like that, you add a new record and you maintain the history. Right? So once you maintain the history, now you need to add, when you have two rows for the same customer, now you should be in a position to identify which one is the latest. So probably you might use the year or the date timestamp or could be have an indicator. So there are different ways in which you can identify which is the latest one. Yeah. So that is about the type 2. Type 3 is adding a dimension column. So in type 2 what I'm doing is adding a row. So in type 3 what they do is instead of adding a new row they add a new column. They add a new column like customer city is there. They will say customer old, customer city old and customer city new. So they will add one more column. Customer city old and customer city new. So they just add one more column. Right. So let's just suppose earlier he was in Bangalore. And now he has moved to Chennai. Right. So in the new again tomorrow again if he changes from Chennai to let's say Delhi, so Chennai will get Delhi. Bangalore remains same. So first and the latest will be maintained. So in between if he changes that history will not be there. Only the first one and the last one will be the latest one will be maintained in type 3.
If we changes location to again Bangalore, both will become Bangalore. So it will be same, right?
Right.
In the,
Right. Right. If we change to Bangalore, it will become Bangalore. Yeah.
so no,
Yeah.
here there will be no conflict, right?
No conflict. No conflicts. Why will there be a conflict?
Now, how you relate
He
this
will,
row into that dimension table?
which time? This is in dimension table. No, this data. This data is available in dimension table. So as I was showing you this customer city, this will be there will be two columns. One is customer city old and customer city new. So there will be an additional column for that.
Just including one more column.
Yeah.
Okay.
Yeah, that's what. See, add a dimension column. This is adding a dimension row. You getting it?
Okay. Okay.
Yeah. So that's how the ETL team handles these three types of techniques, and mostly, like if you look at the majority, people will be implementing the type 2 one instead of type 3, because type 3 what will happen is in case if there are 4 columns, you have to add 4 new columns, right? If the change is happening in 4 different columns, you'll have to add another 4 columns. So let's suppose marital status is there, right? Or customer city is there. So that's the reason instead of having this kind of a thing, adding a new column, type 2 is the most preferred implementation. So moving ahead, handling changes in dimensional model. So whenever we talk about any query?
Rajesh, a little confused. Can you go back to the same types?
Okay. Yeah.
Second and third. Can you repeat again second and third?
Yeah. In case of second type 2, what happens is you're adding a new row in your dimension table. So this is your first row and this is your second row. And you're maintaining the history. You're maintaining the history. Now again, what will happen is you're adding a new record and you're maintaining the history. Maintains the old record. Did you get this? What you're doing is you're not doing any change in the structure of your dimension table. All you're doing is you're adding a new row to this. So you have
one more
row.
question.
Yeah.
If you take customer city as a primary key for some other table,
Customer city cannot be a primary key. City ID might be a primary.
Only primary can be only customer ID. That's it, right?
Over here, it's customer ID.
That's it.
Yeah. So, but generally, when see in this kind of scenarios, what will happen is you might have to add another alternative surrogate key or something which will uniquely identify the rows. So what will happen is when your data, when you're getting your dimension data from multiple sources, let's say suppose, I'll give you one example.
Raj, that's what my
I have source.
see, the customer ID you're giving primary key to some other table. So here you are maintaining two rows with the same customer ID, right? Ravi name. So that will be duplicated, right, in another
No,
table.
that's what I'm saying. Correct. So that's why we'll not be considering customer ID in a data warehouse. In your warehousing, you will not consider this as the primary key. You will have another surrogate key where it will not be related to your application. It will be auto-generated. You will keep a auto-generated key through which you will identify the uniqueness of each of these IDs. So that will be the primary key. So when you talk about the dimension table, so suppose I have three sources. My dimension data is coming from three sources. Let's say customer name is coming from here, and there might be a primary key here, and I might have some customer related address here, right? And some other customer, let's say customer payback points or something like this. So some other data is over here. So when I'm pulling the data from multiple sources to my warehouse, what will happen is I cannot take the custody of my source one as the primary key. I cannot take custody of this particular source one as the primary key because I'm pulling the data from multiple tables. So each table will have its own primary key. So normally I might have to come up with a algorithm through which I create a primary key in the runtime. In my dimension table over here, this is my customer dimension table. So when I'm pulling the data from three sources, I will have to create a primary key. Either I can say that source 1 plus source 1 dot custody plus source 2 dot. So some kind of algorithm I need to come up. I need to come up with some kind of algorithm which can uniquely identify a row in my customer dimension. So it could be S2 dot pk plus S3 dot pk. So something like this, I might come up something like this. So I might join the primary keys of all these three tables and create one additional primary key for my customer dimension. You're getting it? So I'll have to create a unique key in my dimension table. I cannot take this as my primary key because it will not hold good in my customer dimension in my enterprise warehouse. Queries?
What is the primary key you said we are going to define, right?
We are going to define in the ERP tables. But when it comes to warehouse also, we are going to define. Yeah, we are also. What do you mean by we are going to define?
Yes, we are setting up this as a primary key.
Correct. We are setting this as the primary key. So
yesterday you logged into OBIEE, where you have shown one window. In that primary key
is custody.
Yeah.
That's just a sample database, right? I don't have multiple sources over there. So you cannot, that's not a full-blown data warehouse. Let me show you that again. That's not a full-blown warehouse. It's just a dimension table, which is.
Yeah, I understand that one, because the thing is, there also we have to take that pop. What do you say?
The data warehouse will take care of providing a dimension. No, you take any of this dimension. Okay, take calendar ID. It has got a primary key. This is the one, right? Similarly, you take your customer table.
Can you go to the window where you define the primary key?
This is the primary key, right? Yeah, tell me.
Yeah. Not this one.
I'm just giving you one example. I see people can come up with any kind of a width. we call this as a customer bit. Customer bit is something where it uniquely identifies a bit, and this same bit is going to be stored in my fact table. In my fact table also.
Nothing but one particular column, right?
Correct. Yeah, go ahead, man.
No, fine. That's what I was asking, because you are adding so many sources and putting in one column. That column
Correct.
becomes a primary key for that particular
Right.
dimension table, right?
Right. So I
Okay,
might
got
have
it,
a
got it.
custom. You getting it?
Yeah, carry on,
So this
got it.
is a single column. This is a single
Yeah.
column. You'll have a unique, and the same thing goes over here. The same whatever identifier which is there, which uniquely identify every row in my dimension, also goes over here to indicate this particular row. There should be
Okay,
again
fine.
integrated between, right? So over here, let's say suppose this customer has bought something, then let's suppose whatever he has bought, that ID will be here. Let's say sales ID or something, or product ID. It will be here. So you can uniquely identify that this particular customer. From this, you can easily identify that this particular customer who belongs to this address and which belongs to this particular. You can uniquely identify this particular row. Yeah. Any other queries?
Yeah, fine, carry on.
Yeah. So the next thing is how do we handle the changes? What are the different types of changes you will encounter? One is changes to the data. Just now we have seen how do we handle the changes to the data if the data is changing in the dimension, like slowly changing. There might be a situation where you might have to handle very fast changing dimensions. Right? And it might be, to maintain the history in the dimension model, we have different change handling strategies. One of them is slowly changing dimensions. The other one is very fast changing dimensions. So these are something which we have to handle with respect to the data. But there are certain changes with respect to the structure. For example, you might have to add a new dimension to the start schema based on the customer's requirement. Tomorrow, customer will come and say that I want a new dimension to be added to my start schema. So how is that going to add? So that is one of the things which we need to handle. Addition of a new attribute to a dimension. So for example, my customer table is there. In my customer table, I don't have a zip code. So my customer will come and say that boss, add zip code to my dimension table. You will say add zip code to my dimension table. So I will have to look out for zip code in my source table and then create a ETL mapping so that that zip code comes in and gets stored in my customer dimension table. So what we are going to do is we are changing the structure. We are going to add a new attribute to an existing dimension table. Adding a new fact. Similar to this, we might the customer might ask me to add a new fact to my fact table. So that is also changes to the structure. And granularity.
It's a
So what
kind
do you
of
mean by granularity?
type 2, right?
It's a kind of type 2. Yeah, you can say it's a kind of type 3, I would say. So when we talk about type 3, we are adding a new column, right?
Yeah, fine, type 3.
Okay. So granularity of the dimension model. What do you mean by granularity of the dimension model? Any idea what is granularity? Heard about this?
Oh, no idea.
Okay. Granularity means the level of details. Granularity means level of detail. So what is the level of detail we have? So when you talk about the level of detail, when you start designing your fact table or your dimension table, you'll have to understand what is the level of detail you wanted to store as part of your fact table. Let's say suppose you have sources, right? You have sources and you're storing the data at a hour level. Every hour you're storing a lot of data in your sources. But in your enterprise data warehouse, in your fact table, let's say suppose you're storing the data at a day level. You're storing the data at a day level. So I would call this as the granularity. Now I will say that the granularity of the fact table is at a day level. So I'm storing my data at a day level. I could also store my data at a week level. So this particular thing will be decided by the customer whether how he wants to see the data. Now when I say a data warehouse will include detailed data as well as summarized data. So your data warehouse will have both detailed data and summarized data. So when I say detailed data, it could be hourly data or it could be maybe minute data, it could be, right? So whether you wanted to store your data warehouse with this kind of information, or you just wanted to store at a day level or a week level. So that is what the granularity talks about. So the importance of granularity is tomorrow, let's say suppose you are storing your warehouse at a day level, So tomorrow my customer will come and say that, boss, I want a report to be developed at a month level, So what I can do is I can easily aggregate my day level data to a month level. And again, if he comes and asks me, I want the report at a year level, I can easily do that at a year level. So through aggregation strategies, I can easily do this. But imagine a scenario where he comes and asks, boss, I wanted to see the sales at a hour level. So do you think it is possible? No, it is not possible, because we are storing our fact table at a day level. So once you store at a day level, you cannot go down to an hour level. So that is the reason, while building a data warehouse, you need to first understand what is the granularity he is looking at. So changes in the granularity is a very a serious thing, like it might affect the scope of the project, something which you should be looking into before you start building the warehouse. So going up is simple, that is from day level to month level or month level to year level, it's okay, you can easily do it. But going down is difficult. Once you start storing the data at a day level, then suddenly he comes and asks for hour level data, you will not be having it as part of your warehouse, because you're not storing. You're not storing at an hour level. You're only storing at a day level. So it will be difficult for you to handle those kind of situations. So that's about the granularity. Any queries?
Rajesh, granularity means only regarding the time, right, of the data?
Not only time, it could be also, let's say suppose product, let's say product is there. Product, if I'm storing at an ID level, or if I'm storing at a type level, or if I'm storing at a subtype level, right, with respect to the product. If with respect to, let's say, location, you take location, if I'm storing only at a branch level, if I'm storing my data only at a branch level, I don't have at a dealer level. If I'm not storing at a dealer level, then it's going to be a problem tomorrow. So branch level, that's what that is also granularity. Granularity means it could be anything at any level. So if I open this, granularity could be from a customer perspective, like you wanted to store at a regional level or at a district level or at a sales rep level or at a customer level. So lowest level is the customer level. Right. Similarly, over here, if you look at, you have at a type level, if you wanted to store or you wanted to store at a subtype, it's always better that you store the data in your fact table at the lowest level, so that tomorrow, if there is any requirement, you could always aggregate your data at a upper level. Is that clear?
Basically, you're saying hierarchy.
Hierarchy only. So when we talk about granularity again, we have a hierarchy over there, at what level you are going to store the data. Yeah.
So this need to be done at the starting project level itself, right? When you're developing at that time of itself, right?
Correct. Even your database design also depends on that. Understood? Let's say suppose you are storing the data at an hour level. Okay, in an hour probably I'll have 100 transactions. So 100 into 24 into 24 hours into, let's say, 30 days or 365 days. Okay, so this is how you calculate the amount of database space required, right? So it's taking around 8,76,000 rows, right? In case if we are not storing the data at a hour level, then what will happen? This calculation will not be valid. So the if the granularity is at an hour level, you might require more number of rows. But if you are storing the data at a, let's say, week level, you don't require so many rows, isn't it? So based on that only you will
Yeah,
be
fine.
deciding your database. Yeah, estimations are done based on that. So you
And
would
one more,
expect that. Yeah.
can you go back to
Yeah. Tell me.
slides, please?
Yeah.
Here it was mentioned slowly changing dimensions are name, something like descriptive things, whatever you said, marriage status, everything. If it is for very
Right.
fast, can you give me an example?
This is for slowly changing dimensions.
No,
This
fine,
is
fine.
for
That is for,
slowly changing.
yeah,
For very
fast.
fast dimensions, very fast could be probably you take the campaigns are there, right? So if you take
Sorry?
the campaigns, marketing campaigns will be there, right?
Yeah.
Marketing campaigns, today you will come up with one campaign, today, tomorrow you will come up with a different campaign. So campaign is again a dimension data, so, right? So that keeps changing,
Oh, okay, okay, okay.
right?
Yeah.
So how are
Yeah, I
you going
was
to handle
searching for that one actually. What exactly could be fast changing one? Okay, okay.
okay, right. So next is granularity we have seen, right? Any questions on the granularity? So granularity means grain and granularity, which is level of detail or summarization held in your data warehouse. It affects the volume of data as we have discussed. The database size depends on the granularity. So the report performance also depends on the granularity. So let's say suppose you are running a report on, let's say, 1,000,000 rows, 3, 4, 5, 6. Okay, it might take, let's say, 36 seconds. I'm just giving a hypothetical figure. Let's say if I'm running the same report at this is at a week level, and this is at a, let's say, hour level or at a day level. So if I say week level, then equals to, let's say, divided by 7. So this will be my 1,42,857 rows are there. Over here I have got 1,000,000 rows. So if I run a report, it takes 36 seconds to scan this 1,000,000 rows and generate the report for me. But if I run this report at a week level, I might take maybe 36 divided by 7, 5, around 5 seconds it will take. So I'm just giving an example. So if the granularity is low, then the report performance will be very high. If the granularity is low, the report performance will be good. And if the granularity is high, then the report performance will be little poor because you need to scan so many rows. Is that clear?
Yes, Rajesh, fine.
Okay. So the next thing, ETL. So when you talk about the ETL, ETL stands for extraction, transformation, and loading. So let us try to understand this process wherein see, if you look at the process, I think we have been discussing about ETL. So what happens, you have sources and you extract the sources and then transform and move it to the data warehouse. Simple extraction, that stands for E, extraction, transformation, and then load it to your data warehouse. So this is your ETL process. So it is a process by which data is integrated, transformed, extracted from the operational systems or transactional system into the data warehouse. So this is a typical standard ETL framework. You see operational systems on the left hand side, it starts from there. you extract the relevant information, and then you cleanse the data, and then you apply cleansing rules. Then it goes to the integrator, you integrate the data from multiple sources, you do the transformations, and then finally you load the data into your warehouse. So typically this is which happens in your ETL. So your ETL team will be responsible for implementing this kind of a system. So let us see what are the things which are part of this. Objectives, let us see all these things are part of. So we will see how your bad data affects the business, identify situations that highlight dirty data. So what do you think a dirty data is? Like, dirty data is where, let's say suppose one company is buying another company, then you might have to merge their information systems, wherein you have to merge their data sources, right? All these things actually, they lead to dirty data, right? And some of the informations, like especially the dimension or the customer information they have to be merged. In such a case, there might be a customer who is part of both the companies. So in that case, you might face challenges. So how are you going to handle all these things? This is what we're going to learn as part of the ETL. So as part of this, you will understand how to cleanse the data. We'll see what are the different types of transformations, and let us see the granularity and understand the metadata. So these are some of the transformations terms what we generally these people use, the ETL team uses. So let's see one by one. Extraction. Extracting or extraction is nothing but you're capturing the data as is. That means you're not doing any conversion over here, you're just pulling the data which is required for your warehouse. So I might have 1000 tables here, I might have around 800 tables over here, right? I might have around 500 tables over here. So as part of my warehouse, I will not pull everything. I'll just only pull which is required for my data warehouse. Probably 20% of the tables, maybe around 300-400 tables, I will pull from here to my staging area. So this is my staging area. So in my staging area, this is where I do all my transformations. And this is my source. And I do the extraction over here. So I will extract only which is required for me. So from here I might take 400 tables, maybe here I take 100 tables, and from here I take 100 tables. I'm just giving just an example. So extraction is a process where you are extracting the data as it is. You are not doing any kind of conversion here. You're just copying the data. You're just copying the data from your source to the staging area. So sources can be anything. It can be a legacy mainframes, it could be a database, it could be a flat file, it could be anything, right? Then is conditioning. Conditioning is the process where you convert the data types from source to the target data warehouse. So as part of the conditioning, what you do is you convert, probably I might have a cust ID as an integer over here, right? Over here my cust ID might be a character, right? So there might be different types of, all these data types might be different in each of these sources, which I need to convert that and put them in my data warehouse in a standard format. So if this is my data warehouse, so inside this, if I'm pulling my customer ID, first I should declare customer ID here. So I should declare my customer ID, and there should be a, let's say suppose if I'm declaring this as int, then the custody which is coming from this place, it might be char, right? So I need to convert this custody into int before I could load it into my data warehouse. So conditioning will do all these stuff where whatever data types or mismatches are there, those things will be taken care by conditioning. Scrubbing is, it ensures all data meets input validation rules, which should have been placed when the data was captured by the operation system. That means you are actually validating the source data. You are validating your source data. There might be a situation where your operational systems might not have captured certain information, or they might have captured wrong data. So I don't want any wrong data to be part of my warehouse. My warehouse, I want it to be very clean, and it should have a single version of truth. That means I should not have any duplicate data. I should not have any null values. So to ensure all these things, before I could load my data from my sources, I should ensure that the data which is coming from a source is clean data. It has to be clean. It should not have any invalid data. It should not have any null data. So that is the reason we'll be doing a lot of validation as part of the scrubbing. So as part of the scrubbing, probably we'll check for every row. So when you say 400 tables, let's say 400 tables, you are pulling the data of 400 tables. So each and every row will be validated and checked for certain input validation rules. Input validation rules means it could be like you might be doing null validations, or there might be certain data which is numeric but the data entered is non-numeric, right? So all these are some of the examples where it has to validate each and every row of your source system. So your source system validation will be done as part of your scrubbing process. Then you might have multiple sources, right? And you might have a single customer who's spread across 3 applications. So same customer is available in 3 different sources. So in that scenario, how is that you're going to handle? You have to merge this, right? I cannot have 3 customer ID with the same name in my warehouse. I need to have only one single customer. Though my customer data is the same data is spread across 3 sources, at the end of the day when this data goes to my enterprise data warehouse, it has to be a single profile. I should not be having any duplicate customer IDs. That is a merging. Yeah. Sandeep, so silent, no doubts?
No, actually this is purely technical, right? Some programs will be running at the back end to fix all those things. So I'm just listening, right. We can't do anything.
Okay. And moreover, this is not your responsibility actually. As a ETL developer, they will be doing it. As a OBIEE developer, see, I'm explaining you the whole scenario only so that tomorrow when you start working on BI project, you should understand your peer groups. Like you'll be interacting with the ETL team. You might be interacting with.
Yeah, that is the reason. Just listening, because understanding properly the flow.
Right. Right. Just you should understand only the flow. You don't have to get into the depth. It's not required.
Yeah.
You just have to understand. Yeah. So the next thing is householding. Householding is a process where you might, let's say suppose you have 3 sources over here, right? If in a family there are 5 people. Let's assume that there is a family where in a family there are 5 different people, and all these 5 people who are part of the same address, they might be available in different sources. So I need to identify these people of a same family so that I can actually save a lot of amount for my campaigning. So whenever I'm doing a campaign, let's say I'm doing a marketing campaign, I might have to send a catalog for each family, each address. In such a scenario, if I'm trying to do this householding, that means identifying the members of a single or a same household. If I do this, then I'll be able to save a lot because I don't have to send duplicate invitations or duplicate catalogs to the same family members of a same household. So that way I will be able to save a lot in this. So this is also part of this. So you'll be trying to identify, probably using the address, you'll identify who are the part of the, like which are the family members, like who are the customers who are part of the same family. Then yeah, and then you have enrichment. Probably one of the things as part of the ETL is like,
yeah, go back one slide.
This one?
See, household thing, yeah, household thing. You said that very fast changing data in dimension table is
correct.
What do you say? The campaigns, right?
Correct.
So if in a household, if something happened in the house like 1 month ago, 2 months ago, so that data will be wrong, right?
Right. That's not, see, unless until the customer approaches me, I will not be knowing. See, imagine.
See, not 100%.
Right now, no. There is nothing like 100%. I'm telling you, right? I'll tell you one thing. Simple example. How
just
long
to
you
minimize your expenses. That's it, right?
Right. So that's it. Now tell me one thing. How long you have been in Singapore?
2 years.
2 years. So probably I can 100% guarantee that still, in your India address, still you might be receiving certain mails or certain,
Yeah.
right? That happens because as a vendor or as a company, they never know that you are in Singapore. For them, it is a loss actually. Imagine if
Yeah.
those who are sending you these mails and other things, if they come to know that you are not in that address, they would have saved a lot of money, right? It's not only you.
Yeah.
Like that, you might be sending to millions of people. So they just look into their customer database and see the address and then they send it,
Yeah.
right? So
This is one way of minimizing expenses. That's it. I think so.
correct. Minimizing the expenses. Yeah.
Okay.
And enrichment is you're trying to use third-party data in your ETL process, right? So you might connect to the web services of another company, and you get the feed from other research companies to enrich your ETL process. Scoring is basically used for advanced analytics where you wanted to compute the probability of an event happening, whether a particular customer will buy a new product or not. So you will try to do all these things as part of your ETL. So you can populate the required scoring information as part of your ETL process. Loading, validating, again when you say loading, there are two types. Did we discuss about loading before? I guess I told you about incremental load and full load, right?
No, Rajesh.
No. Okay. So when I talk about loading, there are two types. One is you have a full load and incremental load. So when I talk about full load, let's say suppose you have recently developed the data warehouse project, and you have not yet started the processing. You have not yet started the processing of data. That means the data is still in the source, and your data warehouse is just empty. You just have created the metadata. So you have source, and you have your ETL process to be run. You have not yet run the process. It's just developed, and your EDW, which is having the metadata. So there is no data inside this. You just created the metadata. Now, once the data warehouse project is signed off, right, and once the customer gives a go signal, you run the ETL process to move the data from your source to the enterprise data warehouse. So let's assume that you are having around 5 years of data, past data, 5 years of past data. Let's say from 2011 onwards, you are storing the data, your operational data, and from 2011 to 2015 data, you are moving to enterprise data warehouse at one go. That is called full load, right? So that means whatever data which is there in all these things, you are converting that entity relational data, that relational data, into a dimensional data, and then storing that in your warehouse. So up to, let's say, 2016 you are storing. 2016, let's say September 14th, till September 14th you date. Now September 15th data you will not be doing right away, because you can run this process only after the business hours. You can run this process only after the business hours. So September 15th data, what I'll do, I'll run tonight. So today is September 15th, so 2016 September 15th data. September 15th data will go after my business hours. So tonight I will run the process. So what I will run, I will only try to fetch the information which has been loaded into my operational systems after September 14, 2016, because I don't want before data, because it is already there in my enterprise data warehouse. So in my enterprise data warehouse, after full load, my EDW will have data from 2011 till 2016 September 14th, right? Now September 15th data I need to push it to my data warehouse. So this is my incremental load. So my incremental load will run every day. It's an ongoing process. So again 2016, again September 16th midnight, again I will run my incremental, so that I can push 16th data into my warehouse. Again 17th September, again I will run this increment. Like that every day, it's a ongoing process. These are called ETL runs. So these ETL runs will be done after the business hours to push the latest data into my warehouse. Any queries?
So you are saying only full load happens only when the database is new.
Right, right. It's only it's at one go, one-time activity. It's a one-time activity.
So do you change again in ETL process after completion of the full load?
Full load, you will not run the full load. In ETL, you have two types of loads. One is full load and the other one is incremental load. You will run the full load only once. After that, you will not touch that full load. Then
Okay,
you
got
do the
it.
incremental. Yeah. So every night your ETL team comes and runs this. They won't even run. It will be automatically scheduled. It's auto scheduled to run on a particular time. Say so probably they might have scheduled to run the ETL process sometime in the midnight, 12 o'clock. It might run for 1 or 2 hours to fetch the data from your operational sources to your warehouse. Yeah. Any queries?
No, Rajesh, clear.
Okay. Fine. So I think validation is, again, once you load this data from your sources to a warehouse, how do you ensure that whatever data which is there in the sources has moved to your enterprise data warehouse correctly? Let's say suppose I have got around 25,000 customers are there, and now I should see the 25,000 customers in my enterprise data warehouse. So this is what we call as loading, post loading, like like after once you load this, you do the post load validations where you would ensure that whatever data which is there has been moved accurately, right? So how do you do that? You will have to count the number of customers. There might be certain scenarios, test cases will be there to check whether the data is matching or not, or the values are not matching or not, or the row count is matching or not. So all these kind of validations will be performed to ensure that the source data is properly, accurately has been moved to your enterprise data warehouse.
It shows in ETL process itself, I think so, because ETL process, if something is missing, if some issue is there, there itself it will throw error.
It will throw an error. It will throw an error. Yeah. Are you aware of this ETL process?
Yeah, I know. Only the overview I know, the flow.
Okay, okay. Okay, then I think I don't have to explain only.
No, fine, but you are explaining very clearly, which
Okay.
I don't know few things.
Okay. Okay. Then it's good. If it is value addition, then it's good. Fine, then validation and then transformations. Yeah. So I think 8:30 will wind up for the day. So tomorrow I'm going to finish off, I guess we have got ETL data marts. I think from here it will not be much time. It's all simple stuff only. Only the ETL thing is something which is little, time consuming. So tomorrow we'll be discussing about the other transformations, and then yeah, I think we are almost done. Data marts, then we have different types of architectures. Yeah, I think most probably we'll try to finish it tomorrow. Is that fine?
Okay, fine.
Fine, Sandeep, then let's meet tomorrow. Thank you.
Thank you, Rajesh. Bye.